Moving on to the next program. The next program is accessing a record randomly from the binary file. You need to understand the question clearly. Okay, the question is there were 3 names in the binary file of names.bin, right? So the program is seeking a number, a record number, and then based on that number the record should be printed back. As of now, since we are learning the basics, the question may not be clear, but that's absolutely alright. But during the test or the exam, the question will be crystal clear to you, so you don't need to panic. So the question is supposed to work like this. You need to enter 1 and the program should be printing nay. If you enter 2, the program should be returning Leo. If you enter 3, the program should be printing Louis. If you enter numbers apart from these 3 values, the program should be printing not found or invalid number. I hope you are clear with the question. So let's get started. So again, I'll have the record size predefined to the value of 10. Okay, and then followed by record number equals int input. I need to prompt the user to enter the record number based on which I need to the program is expected to show the equivalent name. Input and then enter a record number. So this will be the message to the user. Alright, followed by the width and then open C:/ the name of the folder is temp, the name of the file is names.bin, and the file mode should be read. I'm performing a reading operation, so R, but don't forget to add this B. Alright, so colon. Now the logic of the program is I need to move the file pointer to that particular position where the name will be stored with regard to relative to the record number which will be entered by the user. So when you look at the names.bin, there are 3 data. The first data will have 10 bytes, the second data will have again 10 bytes, and the third data will have again 10 bytes. So we have a uniform size of all 3 data of 10 bytes. Okay, so now the logic behind this program is we need to move the file pointer to the designated place or where we want to actually go to. We have to use a function by the name of seek, f.seek. So this is a new function to you. Seek is a function which will move the pointer in and about the file. I repeat, seek function will move the file pointer in and about the file. Okay, the question is, this f.seek will have to play with the file pointer such that it points to the specific the position. So it has to be like f.seek. So can I do something like this? Record size, and then multiplied by record number minus 1. Okay, so it's so important to have this enclosed because I want to carry out this operation first, followed by multiplication. Otherwise these two will be multiplied first, the answer will not come out to be correct. So make sure that you have this enclosed to indicate that I want the subtraction operation to be executed first. So let's try to understand this statement. Now this is super important. Let's say I open this. I'll open this in order to understand much easier. Where is my Jupyter? Okay, look at this particular statement. Let's say I want to retrieve the name of Leo. For this, the number that I have to enter is 2. This is data number 1, data number 2, and this is data number 3. Let's say I enter number 2. Number 2 will be assigned to record number. The value of record number is 2. The file will be opened in the binary format for reading operation, and then the value of record size is 10. 10 multiplied by the value of record number being 2. 2 minus 1 is 1. Okay, the record number that I've entered is 2. 2 minus 1 is 1. 1 multiplied by 10 is 10. So the answer of this expression is 10. So f.seek will move the cursor or the pointer. It's nothing like bookmark in the book. So the f.seek will move the cursor or the pointer to the 10th position. Which means initially it's here. It's pointing at the 0th value, the first character. So the seek will now move the pointer by 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope you are able to see this cursor. Okay, and then after this, I'm now ready to read the name of Leo. So let's continue further. The name equals f.read. From there on, I need to read how many number of bytes, and that has to be either 10 or record size, right? And then finally, maybe you could first have it decoded first. Since I've read it, it's in binary format, so I need to decode. Encode means while you write it, decode means while you read it. So name.decode, and then finally we are good to print the value of name. So in order to make the program little smarter, say if len of name is equal to 0. When will it be equal to 0? If there are lines with no, if there is a value of name with no characters. So that means we have reached the end of the file. So if this is true, I would like to have a message saying print invalid choice or invalid number. If the condition is false, if the condition is false, then I would like to print the value of name. Okay, that's it, I guess. So we'll run the program and check. Fingers crossed. Let's say I entered 2. Oops, I get to see the error. The error is with regard to f.seek record size multiplied by seek of a closed file. Okay, I'm so sorry. I have made yet another mistake. I'm sure some of you must have realized this mistake. I forgot to put the file handle, okay, as f. Okay, so let's run the program again and check if it works. Number 2 says Leo, and then we'll enter another number for Suarez. Okay, there you go. And then finally for number 1, it has to be Neymar. And if I enter 4, I should get the output of invalid choice. So I hope you have understood this program. Okay, so just a brief explanation of this program. All you need to take note of is this particular statement. Otherwise, the rest of the program revolves around the first three programs, right? So once again, let's say we'll enter number 3. Let's trace the logic. I enter number 3. Record number 3 will have the value of 3. Okay, and then the value of record size is 10. 10 multiplied by 3 minus 1. 3 minus 1 is 2. 10 multiplied by 2 is 20. So this seek will advance the pointer by 20 bytes. So if you start here, it will finish right here. It will finish right here. So this seek will in a way force the pointer to point to the name that we are on the lookout, and then read starting from here till the end. It needs to be decoded. This is in a format of binary, and then before we print it, we just run a check. The length of name is 10. It's not equal to 0, so this condition is false. And then finally it gets here, it will print the name of Lewis. It'll print the name of Lewis. Let's say if you enter 4, what happens? The pointer will start to point right here. You don't have any characters. It'll try to pick up though, but the length will result in 0. This condition will be true, hence you get the output statement of invalid choice. So this is how you write the program for accessing a record randomly from a binary file. Okay, let's go on to the next program. Now the last 2 programs are a little more complicated, so I want everybody to step up your attention. Okay, program number E. Search for a name in a binary file and display record number. So this time it's just the other way around. We have to enter the name, and then the program has to print the record number, the equivalent record number of that particular name. Let's say if I enter Leo as a name, I should get the answer of 2, because Leo stands at record number 2. If I enter Lewis, I should get the answer as 3. Alright, so let's get started. I hope you are clear with the question. First things first, I need to import OS module. I'll let you know a little later. And then I'll have the record size is equal to 10, followed by file size is equal to the size of the file. The example that we have used was names.bin. It's easy to calculate the size of the file in terms of number of bytes. The file has 3 names, 3 data of 10 bytes each, so that makes 30 bytes. But just in case if you have larger programs where the manual calculation is not possible, you can use the predefined function which are defined in the module of OS. So os.path.getSize. So this is a predefined function which will return the number of bytes used in any file. So you need to specify the name of the file. The path is c:/temp/ and then you have names.bin. Be very careful with the name. So this is the path of the file on which this particular function will calculate the number of bytes which are used in the file. So the number of record could be the number of record could be calculated as file size divided by record size. Okay, so this is self-explanatory. What I'm trying to do is I want to check the number of inputs or number of records or number of data. So the value of file size is 30. Since it's a very simple example, it's very useful for us to understand the program. So the value of file size will be 30. 30 divided by 10. The record size, the size of individual record is 10. 30 divided by 10 is 3. So 3 will be assigned to num_record. So num_record will will show the number of data or number of inputs or number of records in the program. We need this. Just to play safe, I'll have this converted to int, because I'm not sure about the data type or file size. It could be float, or it could be some other data type. So once you have the typecast, the ultimate answer will be in the form of integer. So let's move on. Okay, we'll use the width again. Open. Now this time let's not miss the file handle. C:/ followed by temp/ names.bin, and then followed by the file mode of, now this time it has to be, am I writing or am I reading? I'm reading, so it has to be RB and then as F. Okay, and then let's use some variables like position is equal to 0, I need this, and then found is equal to false. The boolean value of true and false always starts with big T or big F. Be very careful. If you just write it like this, it's not a keyword, it's not a boolean value, it's just a ordinary variable. So it has to be like this. So initial value of found is false, which means the name that we are searching for is not found. Okay, now let's move on. We now need to accept the name from the user. So for this, name equals input, enter the name to be searched. All right, enter the name to be searched, and then followed by, I think it's better to convert this to binary format, so that we'll be able to compare the binary value of name with the binary value of the names in the file of names.bin. So I have this converted to name.encode. Okay, so I hope you are clear till this point. After this, for n in the num underscore record, I'll use the range function. So what exactly am I trying to do here is I want to run a loop. that will take us to all the individual record one by one. The value of num record is 3. Okay, so that was calculated as a result of this particular expression. So the value of num underscore record is 3. N will have the first value of 0, then 1, and then finally 2. Okay, let's move on to the next statement. F dot seek followed by position. F dot seek position. The value of position is 0 to start with. So the pointer, in any case, will remain at the first character. Will remain at the first character, and then we'll try to read it. So name is equal to, or we'll use some other name. We'll use nm equals f dot read rec followed by size. Okay, and then again name will have this. Okay, we'll just leave as it is, and then we'll do the comparison between the name and nm. Now this will have the value of the first name, which is stored in the file of names.bin. Okay, so we'll try to run the check. Okay, if name in nm, if the condition is true, then I'll change the value of found to true. Okay, and at the same time I would like to print a message saying name, okay, found, or just to decode this first, I'll just decode this first, and then followed by found at record number I or n plus 1. Okay, and then I'll just complete the program. I think it's better. Position plus you have the record size, and then finally I come out and I run this check again, if not found, followed by print name not found. Okay, so we'll try to run the program and then get on with the explanation. It's better, right? So we'll run this. Okay, I want to search for Leo. Okay, Leo found at record number 2. Okay, everybody, I want you to step up your attention because it's going to be a little complicated, not much though. Okay, 1 minute. I want to, okay, there you go. Okay, we'll just trace the logic of this program. You're clear till this particular moment. The value of position is assigned with 0. The found initially is false. Enter the name to be searched. I enter Leo. Leo. Leo will be assigned to name. And this Leo, which is in string format, will be converted to binary format using the function of encode. The new value of name is Leo, but in binary format. For n in range num underscore record, may I know the value of num underscore record? Quick, it's 3. So the first value of n will be 0, the second value will be 1, and the third value will be 2. That's it. The number itself is not included, as you have learnt in class 11. So the first value of n is 1. F.seek position, the value of position is 0. So in any case, it was at the first character. The moment you open the file, the cursor or the pointer will be pointing at the first character, so this will make no difference as such. So all you need to remember is the cursor will be pointing right at the start. F.read, it will now start to read how many number of bytes. It's going to be 10. So F.read will read 10 number of bytes and it'll be assigned to nm. So the value of nm will be ney followed by how many spaces? 7 spaces. Okay, so all these characters starting from n till the last space will be assigned to nm. I hope I'm clear till this point. If name, what is the value of name? The value of name is Leo in binary format, and the value of nm is ney followed by 7 spaces. So this statement works something like this. Is Leo found in nm? Is Leo found in this? Do you see Leo as a part of this data? The answer is false. Okay, it's not true, it's false. As a result of which these two statements will be skipped or ignored. It then comes to this particular statement. It's now time to advance the position of the pointer to the next record. So the old value of position is 0. 0 plus 10 is 10. So the new value of position is 10. From here I go up to the next value of n. This is the body of this for. So the first loop is over. I now need to continue with the second loop. I go up, the value of n is 1. Earlier it was 0, now it will change to 1. F.seek position, the new value of position is 10. Remember? So this seek will advance the pointer to the 10th position. So this is the 10th position. This is the 10th position. Alright? And then it will read starting from L till the last space, the 10th, the 7th space. It will read it. So the new value of nm is Leo followed by 7 spaces. I hope I made myself clear. NM, the value of NM is Leo followed by 7 spaces. The name has the constant value of Leo because the Leo is the one user entered to be searched for. So the value of name is just LEO but in binary format. Is Leo found in NM? The value of NM is LEO followed by 7 spaces. So is LEO found in Leo followed by 7 spaces? The answer will be true. If the answer is true, if the condition is true, I'll have to execute these 2 statements. True will be assigned to found. The new value of found will now be true, indicating that the record that we are on the lookout is now found. And then print name.decode. I got this name, I got the name decoded first, otherwise it's in a binary format, so I want to have this converted to the plain text mode for printing for us to understand. And then Leo, LEO, found at record number n+1. The value of n was 1. Remember, this is loop number 2. Loop number 1 has n value of 0. Loop number 2 has n value of 1. So this is where we we take the help of n to trace out where exactly the name to be searched for is located at. So it is through the variable n that we are able to keep track of at which record number the name to be searched for is residing at. So the value of n is 1. 1 plus 1 is 2. So this the statement will be printed as a result of the execution of this statement. And then again the position will be advanced by 10 more bytes. You never know, the same name could be locating at several different places, in which case all the record numbers of Leo will be returned. So again it goes back, the value of n will be 2, the pointer will be advanced to 30th till here, it picks up the lowest, the condition will be false, and then finally when the loop gets over it comes out and then it checks this. The value of found is true, is it? The value of found is true thanks to this particular statement. As a result of condition being true, the value of found has been changed to true. The value of found is true. Not of true is false. Not of true is false. When you look at this if not found, from the general understanding of English, it's easier to understand. But technically the explanation should be the value of found being true. The not of true is false. So the overall condition of this statement is false, which means this will not be executed. Let's say if I search for, say, PIQUE, when I press enter, I get the answer as not found. The reason is this particular condition will never ever be true. If this condition never ever remains true, these 2 statements will never execute it. The found value will never change to true. It will always remain as false. If it remains as false, not of false is true. So the overall condition is true. Hence I get to see the statement of name not found. Alright. So let's check the time. Oh, it's 1 hour and 7 minutes already. So let's not do program F today because it's a little lengthy. It will take at least 15 minutes. So I would like to end today's lesson on this with the program of E. So I hope everybody has understood the logic of these programs. It's not just enough to look at the program and write it with little understanding and no understanding. It's a big mistake. First you need to understand the program completely in its logical terms, and then once you're comfortable with the logic of the program, then you can move on with the programming just in case if you still have some doubts, you could look back at the copy and then do it all over again. But you need to keep practicing this again and again until you have complete mastery over these 5 programs. The first 2 programs are pretty simple, but I want everybody to focus especially on the last 3 programs. So with this, I would like to wind up. I wish everybody great health. Please continue to take good care of yourself. And then these are not holidays, these are technically very much school days. So please study hard, and then by the time when you come back to your school, you'll be completely ready by then. Thank you very much.